Okay, hi everyone. I want to work through this problem, which is one that covers historical returns, expected returns, and required rate of returns. It's problem 6-13. Okay, we have some observations on stock X and stock Y in the market, which appears in this table right here to the left of my mouse. Okay, so we've got some historical information for years 2003 to 2007. All right, and we're told to assume that the risk-free rate of return is 6% and the market risk premium is 5%. Part A says, what are the betas of stock X and Y? Okay, now, before I want to solve each part of this problem, I want to go over the two formulas that you see right here and right here. Okay, first, the left one is the formula for the beta for stock I. And I want to focus on this area right above my mouse here. And what we see is we consider beta to be the correlation. Well, let me sort of say this first. Let's look at the first symbol. Okay, sigma I is the standard deviation of stock I's stock return. So the nth stock's return. In other words, the standard deviation for the stock we're interested in, where sigma m, the bottom term here, is the standard deviation of the market's return. And this symbol here, which I believe is pronounced rho of I of m, okay, represents the correlation between stock I, the nth stock's return, and the return on the market. Okay? Now, that's a formula way that you could calculate what the beta is. But there's other ways as well, and one is to simply determine the slope of a line or determine the linear regression formula between the market rate being the independent variable and the dependent variable. So let me illustrate how we can calculate beta of stocks X and Y. All right, let me slide down here. Okay, now I've slid to give us some room, and you can see here was the data that we had originally in the problem, and here I've just lined it up to show you that the market is the independent axis, the return on the market, and then we'll look at the dependent axis for X or Y. And I'm going to calculate the beta for stocks X and Y in three different methods, or using three different methods. All right, first thing what I want to do is grab this right here, and I'm going to insert a scatter diagram. Okay, and you'll see a little bit of it appear on the screen. Then I'm going to move it over here, and give me a minute and I will reformat this so I can show you what I've done. Okay, now all I've done is added some labels. The independent variable appears on the x-axis, and that's the returns of the overall market, so I labeled it market returns. The x-axis is stock X returns, and we've dropped in the data points. And using an XY chart, we're comparing the paired results of what did X earn when the market earned one amount, and what did X earn when the market earned a different amount, right? Okay, so then what I'm going to do is right-click on this. I'm going to pick the data points and add a trend line. I know you're seeing some of this, but not all of it. I'll slide this over here. I want a linear trend line, and I would like the equation on the chart. I'm going to hit close. And right there, we've computed the beta for stock X. It's that value right there, the 0.9981. It represents the slope of the line, right, in a linear regression format. Okay, let me slide it down and I'll illustrate a couple other ways to do this. Okay, now we could use the slope function or the line EST function in Excel, and all of these will do the same thing. So I'll type in the word slope, hit my left paren, we'll call up the formula, it says give me the known y's. The known y's happens to be stock X right there. Then we'll give it the known x's, which is the return on the market in the same period. Enter that, I hit OK, and I get 99.81%, exactly the same number that I got using the linear regression approach. I can use line estimate as well, which is an Excel function to estimate the slope of the line. And the known y's are these values, and the known x's are these values. And again, bring that down, hit enter, and I get, again, the 99.81. Now what I'm going to do, rather than illustrate, well, let me use the same slope and line estimate to calculate the beta for stock Y. So I'll do slope. Known x's would be these values now. Oh, let me call it up here so you can see me do it there. And the known y's again are the return on the market. So I get, oh, I've got a error there. 0.886.3 is the beta, or 0.0863, right? You could do it each way. Oh, excuse me there. And now let me do a line estimate. Known y's, call it up. Right there. Known x's, right there. And I come up with the same answer as well. Okay, now I want to slide down and I'll show you that I also came up with 8.63 using the linear regression. And here all I really did was copy this chart down here. Then I changed my data points so that instead of it referencing from column, what was it, column G, I changed it to column H right there, right? Because the X values are still the same and the Y values are still the same. And when I do that, we wind up with a beta of 0.0863 or 8.63%. Okay, now with that information, we can answer the problem. And the first problem I'm sliding up says, what's the beta of stock X and Y? Okay, so the beta of stock X, I'm going to turn these into a number format rather than a percent format. Okay, so what's the beta of stock X and stock Y? Well, the beta of stock X is that number right there, which is 0.9981. The beta for stock Y is 0.0863. B says, what's the required rate of returns for stock X and Y? Now we use this second formula, and what we know is the security market line tells us that we can calculate a required rate of return by taking the risk-free rate plus the risk premium of the market times the beta. So why don't we go ahead and work that? Okay, now I've moved the graph out of the way so we have some room to work. But using that formula, we know the risk-free rate of return was given in the problem as 6%. So we can take that as being 6%. And then we have to add that to the risk premium. The market risk premium is 5%, times the beta, right? So I'll multiply it times the beta for stock X, which is the 0.9981, and we come up with a required rate of return. I'll turn it back into a percentage of, well, if we actually round it to one decimal place, it's 11%. If we do the same thing for stock Y, we just copy it over, and we come up with 6.4%. Okay, then part C says, what's the required rate of return for a portfolio consisting of 80% of stock X and 20% of stock Y? Let's work that one. Okay, here's the easiest way I know how to do that. I dropped in the weights of 80% here and 20% here. Let's just multiply them then. The required rate of return of stock X was 11% times 80%. Up, I can format this to something we can use. We'll just take it to one decimal place. And if I copy it here, I get 1.3. Well, since that's an 80% weighting and a 20% weighting, if we add those together, which I'll just do right here, we'll take the 8.8 plus the 1.3, and so the answer to part C was a required rate of return of a portfolio consisting of 80% stock X and 20% stock Y would be 10.1%. Okay, then part D says if stock X's expected rate of return is 20%, is stock X under or overvalued? Well, we've already calculated the expected rate of return according to the security market line, or I should say that's the required rate of return. And the required rate of return according to the security market line is 11%. If the expected rate of return is 20%, then stock X must be undervalued because its expected return, let me state that again, please. Hang on one second. Yeah, stock X is undervalued. I got crossed there a minute because the expected rate of return of 22% exceeds its required rate of return, which is given by the security market line. So as a result, stock X would be undervalued. And that takes care of this problem, everyone. Thank you.